Again, good morning, grade 7. Let's continue with the discussion. We are still in common basis. Okay, the use of common basis. Okay, again, for sodium hydrochloride, this is used for as bleaching agent. Okay, your sodium bicarbonate is actually used as baking soda. Okay, used in baking. So these are the common acids and bases. Okay, let's take a look at handling acids and bases, how to handle them, especially in the laboratory. Okay. In your higher years or in the middle of this class, I might have, okay, we might have some of the experiments, and I want you to be responsible enough in handling acids and bases. Okay. Strong acids like hydrochloric acid, sulfuric acid, phosphoric acid, and nitric acid, and bases like sodium hydroxide, calcium hydroxide, and potassium hydroxide can be corrosive to human tissues. It can actually dissolve your tissues. Okay. Safety precautions should be practiced when handling these chemicals in the laboratory. This is the main reason why you need to have your laboratory gown, your lab gown. Why? This is for your own protection. That's the main reason behind. Okay? This is not for aesthetic, but rather for protection. Okay? I don't want you to be harmed with regards to handling laboratory activities or doing the laboratory activities. You need to what? You need to have your own lab gown in having laboratory. Right? Do you have any questions so far? Questions so far, grade
Yeah,
7?
none, sir.
Okay.
Noted.
Number 1, use hand protection like surgical gloves and appropriate for acids and bases. Okay? Again, use hand protection appropriate for acids and bases. For acids and bases, we usually use rubberized gloves. Okay? Second, wear safety glasses or goggles, especially if the acid and bases has an external reaction. Okay, external reaction includes um if it creates heat or if it creates sparks. Okay. The third one, always wear your laboratory gown. That is for your protection. Okay, let's move forward. Fourth one, if an acid or base enters your eyes, again, or comes in contact with your body parts, flush the affected part with plenty of water, then go to the clinic at once. Okay? This is the main reason why in our laboratory, if it is already finished, it has its own shower and lavatory. Okay? So again, if any acid or base enters your eyes or come in contact with your body parts or parts of your body, you need to wash it directly with water, running water. Or if you are spilled out with acids, you need to take a shower immediately. That is for your protection. Okay. The fifth one, dispose some chemicals properly. Proper chemical disposal. I'll be discussing this one in your laboratory safety precautions. Okay, how to dispose some chemicals properly. Neutralization reaction. Okay. The process of combining acid and base is called neutralization, to neutralize an acid, or neutralization reaction. Okay, please take down notes. Neutralization reaction is the principle involved when a person with hyperacidity, okay, takes an antacid like aluminum hydroxide or magnesium hydroxide in small doses to neutralize the acid in your stomach. Okay, that is actually neutralization reaction. A safe way to find out whether a substance is an acid or a base is through an indicator. Okay, sometimes we use litmus paper, or sometimes we use a liquid acid indicator. Okay, an indicator is a substance that exhibit on color when added to acid or another color when added to base. Okay, so just like your litmus paper, it will give us an idea if the substance is an acid or a base. The acidity or basicity of a substance can be described using the pH value. Okay, the pH scale ranges from 0 to 14. Okay, a neutral solution has a pH of 7. Okay, a pH value lower than 7 indicates that the solution is acidic. Okay, while the pH value higher than 7 means that the solution is basic. So the neutral pH value is actually 7. Do you have any questions so far? Question?
No, sir.
Okay, let's move forward. Acid in the environment. Okay, acid rain is a mixture of wet and dry deposition from the atmosphere containing sulfuric acid and nitric acid. Okay, wet deposition refers to acid rain, fog, mists, and snow. So your sulfuric acid are from your if in case there is a volcanic eruption, so tendency is it will also what? The atmosphere also collects sulfuric acid. And the nitric acid there is actually the reaction of your fog, which is again a product of what? Air pollution. That's the main reason why if there is air pollution, there's always an acid rain. Okay? If acids in the atmosphere are blown into areas where water is wet, the acids fall to the ground along with the rain, snow, or fog or mists. The acid water then flows over through the ground in the areas where weather is dry, and the acid combines with dust and smoke and fall to the ground through dry deposition. Okay. Again, if we have wet deposition, okay, your acid rain, if it falls to the ground, okay, it will actually what? It is actually falling to the ground in a dry area. It is called dry deposition. Okay? Dry deposited gas or gases stick to the ground, building homes and cars, monuments, statues, and trees. Okay? They are actually washed away from this surface by rainstorms leading to runoff or surface runoff, which makes, again, the resulting mixture more acidic. Okay? Reaction of bases. That is actually your acid. So have you observed, okay, some of the status or status in your area? The monuments, okay? You try to look at them. There are a lot of spots there, okay? The spots there in your monuments are actually dry deposit, okay? These are the reaction of acid towards your monuments. Okay? Those are acids. Okay? Reaction of bases. Other acid rain, by the way, can actually damage some plants, like their leaves. Okay? If a plant hit by an acid rain, it will eventually die. And you can actually observe their leaf to have what? To have marks on them. Reaction of bases. Besides reacting with acid in a neutralization reaction, bases are really corrosive. When you say corrosive, or a corrosive substance destroy or damage another substance with its coming when it or which it comes in contact to. Okay, so when you say corrosive, tendency is it is damaging in another thing that's being corrosive. Okay, corrosive is often associated with acids and caustic for bases. Okay, corrosion, right? The main hazard to people of corrosive substances include damage to eyes, skin, and tissues under the skin. Okay, the corrosive property of acid and bases come from their ability to catalyze the hydrolysis of fats. Okay, both strong acids, hydrolysis of fats or the chemical process of decomposing fats. Both strong acids and bases denature or modify the molecular structure of protein and dehydrate them. Okay, that is actually the reaction of what? Acids and bases. The corrosive reaction of acids and bases. Bases also reacts with few metals to form new compounds. For example, sodium hydroxide reacts with aluminum to form gelatinous aluminum oxide. This also reacts to non-metals like how calcium hydroxide reacts with chlorine to form bleaching powder. Those are just few of the reaction of bases. Okay. I think we already discussed everything. So you need to take down important terminologies there. Okay. I am encouraging everybody to download this PPT. Okay. You just need to click this one, the Google slide, and automatically it will give you a route to the Google slides to download your PPT. Do you have any questions so far? Questions so far, grade 7?
None, sure.
All right. I think we had
Answer.
discussed a lot. I think that will be all for today, class. Have a nice day, grade 7. Take care. Bye-bye. Enjoy the rest of the day.
Bye-bye.